Hello, this is Cosmic. The analysis of astronomical data is performed exclusively by visualization. Astronomers view graphs, plots, and images representing various kinds of astronomical data. They also use written words, mathematical equations, and additional graphs, plots, and images to describe their analysis and results. From what other perspective might astronomical data be analyzed and represented? I propose that the sound of astronomical data be used as a valuable complementary tool to visual analysis. In addition, might there be some aspects of astronomical data that has more value being heard than seen? Data may be represented by either a single sound, one or more frequencies with one or more waveforms played simultaneously, or a time-varying sound, what would be called a song or music. Based on my preliminary work, I make a single assumption. The coherence of information is invariant. This means that if there is coherence in data from one perspective, there will be coherence in the data from any perspective. So just as there is a recognizable pattern or harmony seen in the image of a spiral galaxy, there will also be a recognizable pattern or harmony in the sound produced from that image data. So what does astronomical data sound like, and what music does it play? My preliminary work answers this question by concluding that 1. It depends on the nature of the data. 2. Different aspects of the data, for example relationships, can be used to create different sounds. 3. Each aspect is represented by a particular sound. And 4. The quality of the sound has much to do with the structure of the sound itself, for example its waveform and shape. In addition, I hope to discover and/or create tools to do audio analysis that add value to the overall results of the research. For lack of a better term, I call these core sounds. A core sound is a sound that represents a particular kind of data in a particular aspect that adds value to the results of the analysis. When these core sounds are marketed as either hardware or software, they will be named what some of my supporters choose for them. Ultimately, I would like to answer the question, can audio information add value to the analysis of data? And if so, how? A successful project will answer this question in the affirmative and result in the development of analysis skills and tools. In addition, 3 possible commercial outcomes of this work would be 1. Start a company that does contract work performing audio analysis of data. 2. That same company would develop and market software and hardware tools that would allow researchers to do the audio analysis themselves. And 3. Market educational games, experiments, demonstrations that allow students to create sound or music from astronomical data. Here are some additional details about the areas of interest I will investigate. Number 1. The nature of the data. This area of research investigates how different kinds of data determine what sound is ultimately produced. Listening to them in the same way, do all images of spiral galaxies, for example, share a similar sound? Does spectral data sound different than image data? My methodology will entail surveying the various forms of astronomical data that exist, like images, spectra, photometry, polarimetry, etc. And then for each form of data, different aspects of the data can be extracted to create a sound. Number 2. What aspects of the data are being used to create the sound? Some of my preliminary work in this area dealt with the positions and motions of the 4 Galilean moons of Jupiter, Io, Europa, Ganymede, and Callisto. I obtained heliocentric position vectors from the JPL Horizons website. I've written software to take that position data and calculate positions relative to Jupiter and to each of the other moons. From positions, I calculate distances. From distances, I calculate velocities. From velocities, I calculate accelerations. And from accelerations, I calculate changes in acceleration. Each of these values can be represented by a particular audio frequency, which will change over time as the value changes, and we get a song. In this way, I can listen to how the moons are moving. These are just a few aspects within a much larger set, and with one very small piece of data. In the example above, simply the heliocentric positions of the Jovian moons. I want to spend a lot of time investigating what aspects of different kinds of data are required to create a particular sound or song that has potential analytical value. My sense is that this is a huge area of investigation, and I hope to enumerate the set of perspectives possible for different kinds of data. Here are the sounds produced from the motion of the Galilean moons described above. The first is the distances between each of the moons. The second is the velocities between each of the moons. And the third is the accelerations between each of the four moons. Number 3, how each aspect is represented by a particular sound. So how should data be represented as sound or music? This will study how each data value can be mapped to an audio frequency and ultimately to a particular sound or song. The mapping can be simple or complex, and I will create, model, and study various mapping functions. One possible outcome of this will be to determine that particular mapping functions work best for a particular kind of data, which will help in discovering and creating tools to do the audio analysis. So here are some sounds produced by using different pieces of information about the 7 brightest stars in the constellation Orion. The first is the angular distances between each star, and in this case, the larger the distance, the higher the frequency. The second is the visual magnitude of each star, where the brighter the star is, the higher the frequency. And the third is the distance of each star to the Earth. So the larger the distance, the higher the frequency. Number 4, the structure of the sound itself. This area of research has to do with the creation and synthesis of the sound itself. This will be a study in 2 areas. Number 1, the creation of waveforms, and number 2, the creation of the sound using a musical synthesis and the ADSR, the attack, decay, sustain, release methodology. The structure of the sound could be determined by different aspects of the data, or be created and manipulated by the user. Number 5, combining audio and visual as an analysis tool. I'll spend some time investigating the possibility of creating video that allows the researcher or analyst to see the data while it's being played. They will be able to play, pause, rewind, fast forward, or stop at any location in the data stream. Number 6, sound as an educational tool. If audio analysis proves to be viable, I will investigate the educational uses of this tool for both children and adults wanting to learn more about astronomy and the sciences in general. I will develop audiovisual games that will allow students to play astronomical data, and in so doing they will learn more about the data than they would with only visual information. Audio experiments and demonstrations will also be developed. Number 7, a podcast. Initially, there will be a podcast produced once a month to discuss and listen to sounds or music created from astronomical data. The podcast will focus on both the scientific and artistic value of the sound or music, and listeners to the podcast will be encouraged to submit their own sounds or songs for airplay and discussion. The timeline for this project is 6 months. At the beginning of month 5, I will evaluate the progress of the project, and if I anticipate accomplishing all of the work described above, or I'm satisfied with the progress I'm making, then I'll create a new crowdfunding campaign to continue the work. The budget for this project is $500. Some of the money will be used to purchase a dedicated computer for this work. Some of the money will be used to register and create a website highlighting and discussing this work. The remainder of the money, if there's any left, or any additional funds above the requested amount, will go to myself to compensate for a portion of the work I will put into this project. I will use those funds to support my independent astronomical research.